Okay, so we are finishing the 4.8 from yesterday. We were to the point where we needed the factored form of the equation. I'm going to do this one a little bit different just so that I can show you how the answers are and then what you would do if you didn't do it that way, okay? Putting these in factored form is probably not the way that you would solve it, I don't think. Most of you, when you don't have three things to put in factored form, you're like, I don't know what to do. So that's kind of what these are going to do. So I'm going to show you kind of what you get. I'm going to show you how you can kind of do it another way and just write it in the factored form still. Okay, so I'm going to show you something a little different probably than the book has. So the first thing we're going to do is take out as much as we can. So can we take anything out? A 2. So I'm going to put that in parentheses. So if there's not an equals, don't divide by it. Just sit it outside. So I'm going to put a 2 on the outside. And then I'm going to write what's left. So I factored out the 2, so I still have an x squared. If I take 2 out of 32, I divide them, and I get plus 16. Now, here's the point where you're like, ooh, factors of positive 16 that add up to 0, can we do that? No. If it was minus 16, could we do that? Then we could. Then we have 1 plus and 1 minus. So think of it kind of like that. So if you need factors of 16 that don't have any middle terms, it's probably going to be the 4 and the negative 4. So keep that in mind. We're going to put this into the quadratic so that we can see exactly what we need, and then we're going to put it back in factored form. Okay, so it's not how the book did it, but I don't care. I think you'll get it this way better. So I'm going to rewrite it like 2x squared, and I don't even really need the 2. Let's go x squared plus 16. There would be a 0, x in the middle, plus 16. So my a is 1, b is 0, c is 16. Okay, so I'm only working with this part right here because the 2 just makes the numbers bigger. So x equals, negative b would be a 0. If I put a b squared in there, I still get 0. Minus 4 times 1 times 16. And then 2 times 1 on the bottom. So if I have 0 there, do I have to write it? No, the 0 plus or minus. So it's really like there's nothing there right now. When I look into the square root, the discriminant part, I get a negative 4 times 16. That's like negative 64. So right now I have plus or minus negative 64 over 2. You can write the 0 in there if you want to. I just don't want to. Yesterday we learned what to do with that negative. What do I need to do? Put an I, and you can either put it ahead of the square root or after. It's just not underneath. I'm going to just put it ahead of it today. So what's the square root of 64? 8. Oops. There. So we get plus or minus 8i over 2. And we can simplify that. So we get plus or minus 4i. So do you remember at the beginning when I said it's probably going to be a positive 4 and a negative 4? The only thing we really needed was the I part. And until you actually do it to see, oh, that's what I needed, these don't necessarily make sense. But we still need to put it in factored form. So it's really small over there. So right now we're looking at putting this into factors. The only thing you have to do is separate the 2 and bring it to the left. So I'm going to say x equals negative 4i, or I should do positive first, and x equals negative 4i. Bring it to the left. So this one becomes x minus 4i. And this one becomes x plus 4i. And the 2 things that you get when you bring them to the left are the factors. Okay, now that we've seen one, you might not have to go through that whole thing, okay? So my factored form is 2x minus 4i, x plus 4i. Now let's do one more so you can see it without all the quadratic stuff, okay? When you look at 81, what do you think the numbers are? 9 and 9. So what do I need to go with it? When there's no middle terms, I, especially if it's positive. If it's negative, that's a whole different deal. So you're going to do x plus 9i, x minus 9i. So it's really like you're square rooting both of them, but in order to make those middle terms cancel, you need that I with it. If you FOIL it, you should get what you started with, so you can check it. We'd get x times x would be x squared. A negative 9xi and a positive 9xi cancel. They don't make sense, but they cancel. And then when you get a 9i times a 9i, you get negative 81 I squared. And what would that I squared turn into? Negative 1, so negative 81 times negative 1 would be 81. Okay, so it works. It's just kind of different in how you come about it. Yep?
The only reason that we did the quadratic was because the number was in front of the x?
Because there weren't any terms in the middle.
Oh, no.
Yeah. So you could do the quadratic on this one too, but now that we kind of know what they look like, you wouldn't necessarily have to. So you can do it either way, but even if you do the quadratic, you still have to turn it into factors. You can't just leave it x equals plus or minus 4i. You still need to turn it into factors. If it's a factor equation that doesn't involve i's, I wouldn't let you use the quadratic on it. Okay, and you wouldn't have to. So either way is okay, but you still need to end putting it in factors. And remember, that's just bringing it to the left, throwing some parentheses around it, and writing it all together. Now there's one more thing that I want to look at, and we kind of just did it. So we're going to do two of these. I'm going to do one now, and then you guys are going to practice one that looks a little different, and then you can finish the assignment from yesterday. So with this one, they're asking for the actual answers. So we're going to put this in the quadratic. Everything's on the left. Everything's in the right order. So A is 2. B is negative 3, C is 5. All right, so what is a negative 3? 3. Plus or minus. Negative 3 times negative 3 is 9. Minus 4 times your A times your C. And then 2 times 2 on the bottom, 2 times A. The rest is all simplifying. So if you can get the numbers in the right place, that's the majority of the question. These are probably going to be negative numbers under the square root now today, because that's what we're practicing. So 3 plus or minus. 8 times 5, that'd be 40. So we get a negative 31. And a 4 on the bottom. And we are super, super close to being done. The negative under the square root, we're going to turn into an I. And can we simplify the square root of 31? No. Okay, so this one looks a little bit different here. So 3 plus I square root 31 over 4 is one of my answers. 3 minus I square root of 31 over 4 is the other. Your answers to the quadratic are going to look a little bit different than they do when you complete the square. The only difference, you'd get exactly the same answer, which we can't really do completing the square with i's in them, but you would have 3/4 minus square root 31i over 4. They would just be written separately is basically the difference. So With quadratic, you can leave all that stuff bunched together as long as it's simplified, but you do have to still write two separate answers. Okay, we're going to do one more. This one looks a lot like the one we just did, so I'm not going to do one like that. This one looks a little bit different, so I want to do this one instead. So on your assignment for today or a piece of scratch paper or whatever, why don't you try this one? Everything's in the right order. So we'll put it in the quadratic. So you should have started with a equals 1, b equals -4, c equals 5. And of course, on the test this week for the semester, you don't have to memorize the quadratic. You would have it written probably on the board. So -b would be a 4. B squared would be 16. And then on the bottom, 2 times 1. Okay, so you should be sitting somewhere with 4 plus or minus square root -4 all over 2. So we're going to turn the negative into an I. And then what's the square root of 4? 2. So this one simplifies out a lot better than the last one. The last one was a square root at like 13 or whatever, 31. It didn't simplify. This one does. So we're going to write it like this. 4. No, I'm going to do something different first. Okay. 4 plus or minus 2i all over 2. So the square root of 4 becomes 2. There's no square root anymore, and it's just 2i. Now, you're going to simplify this and write it as two separate answers. As long as you can simplify all of it at the same time, all three of these numbers, you can do it. So it looks like this. 2 goes into 4 2 times, 2 goes into 2 1 time. You have to have that number going into both of those. So this would become 2 plus I and 2 minus I. So sometimes your answers simplify out a little bit better than others. What if only one of those simplified? Okay, so I'm going to give you just a little bit different example here. What if it looked like, and this one's totally made up, so it's probably not anything that you could get. What if you had something like that? Could you do all three at the same time? No, if you can't, you can leave it like that. You can just go to your two answers and go like this. 6 plus I all over 2, even though the 6 and the 2 can be reduced.
Could you make it half I?
Yep, and I'm going to do that next. Or you could do 6 minus I over 2. Those work. Or you could do 3 plus I over 2, or 1/2 I. It looks better like this. And then 3 minus 1/2 I. Thank you. Okay, so you can simplify them, but you have to do them separately then if you're only going to do the one. What I don't want you to do is just cancel that out and make it 3 plus or minus I, because that isn't the same. Okay, but so if you're going to simplify, I kind of like to do it this way, because then I don't forget to do something. But if they don't both simplify at the same time, you can leave it. It looks different, but it's okay. If not, you can simplify them separately, and then one might be a fraction and one might not be.